For example 2, you're asked to solve the following quadratic equations. Now, when you have them in standard form, which B and C are, this one is not, one way is to try to factor, but factoring doesn't always work. Factoring is only going to produce a solution for you if you have rational solutions to the quadratic equation, which you're often not going to know about until you actually go through and solve it. If you try to solve it by factoring and it does not have rational solutions, or we were going to talk about momentarily non-real solutions, it's not going to work. So you really don't know what the solutions are until you actually find them. So factoring it's not always necessarily the best way of handling it. So if you're given a situation in standard form, we'll use the quadratic formula and a lot of times if we don't notice what it would factor. Or we could look at a situation like this and realize, well, there's only one variable of x, even though it's still quadratic. If I were to FOIL this out, I would get this, be able to written in standard form eventually. However, since it's already kind of in a factored form, I'm going to make use of that in this situation. So if I'm looking at A, and let's make these a little bigger so we can see them better. Here I have an x minus 4 being squared multiplied by 2 and added by 5 equaling 13. Well, for this, I'm just going to start moving, I'm going to isolate the variable x because I only have one variable of x appearing here, whereas these other ones I have an x squared and an x, which prevents me from just using basic algebra. So here, I'm going to subtract the 5 first from both sides. I'm then going to divide both sides by 2. Now to get rid of the square, because I can't remove anything that's inside the parentheses till the parentheses can go away. The parentheses cannot go away until the square's gone. I'm going to square root. Now anytime that you have to square root in order to solve an equation, a plus or minus symbol needs to go with it because there's two things that I can square to get 4. I could either square a positive 2 or a negative 2. And so when I add 4 to both sides, I get either 4 plus 2 or 4 minus 2. So those would be the two solutions. I'm going to have 4 minus 2, because they want this in numerical order. That's going to be the smaller value. That's going to be 2. And 4 plus 2 would be 6. So those would be the two solutions to this. That's why when you look at the quadratic formula, you have a plus or minus symbol in that too. And for this one, that's what we're going to use. But in order to use the quadratic formula to solve a quadratic equation, you need to have it set equal to 0 first. If you don't do that step and you run the quadratic formula, you're going to get an incorrect answer because you don't really have, in that case, the A, B, and C values, what they really should be for that circumstance. The quadratic formula is used to find zeros. So you need to have an equation that is set equal to 0. So for this one here, when I rewrite this, I'm going to subtract 13 from both sides and get 3x squared plus 4x minus 20 equaling 0. If I would have a situation where all of these are divisible by the same number, I would certainly do that to both sides because ultimately 0 divided by a number is just going to be 0 again, and make the values I have to work with in the quadratic formula smaller and less likely for me to make errors as I make calculations. But for this, using the A, B, and C values in the quadratic formula, I'm going to do x equals negative 4 plus or minus the square root of 16 minus 4 times 3 times negative 20 all over 2 times 3. So the opposite of B, plus or minus B squared, which is 16, minus 4 times A, which is 3, C, which is a negative 20. Common error is a lot of times students leave off that negative, and that causes some problems, and you get situations where you're trying to take the square root of a negative, and that leads to issues we're going to talk about momentarily. 2 times A is 2 times 3. So as I simplify this, what's inside the parenthesis becomes 256, which is a perfect square. It's 16 squared. So I have negative 4 plus or minus 16 over 6. Negative 4 plus 16 is 12 over 6. is going to be that, and negative 4 minus 16 is going to be negative 20 over 6. This will become 2. This will simplify to a negative 10/3. So when I write these in order, and because it wants decimal places if needed, because negative 10/3 would be negative 3.3 repeating, I'm just going to use negative 3.33 for that, and this is just going to be x equals 2. Likewise for this one, I'm going to first subtract 4 from both sides to get 4x squared minus 11x minus 14 equals 0. I have to have it set equal to 0 to use the quadratic formula. I'd also have to have it set equal to 0 if I wanted to factor it too. None of these are divisible by the same value, so I'm just going to start using the quadratic formula. So I'm going to have the opposite of b, which is the opposite of negative 11, that's a positive 11, plus or minus the square root of b squared, negative 11 squared is a positive 121, minus 4 times a, which is 4, c, which is negative 14, all over 2 times 4. As I work this out, I get the square root of 345, which is not a perfect square. So you're going to have two answers for this. You're going to have 11 plus the square root of 345 over 8, and 11 minus the square root of 345 over 8. This will be the smaller one because you're subtracting up here. This would be the bigger one because you're adding. So this one will go first. If you do 11 minus the square root of 345 over 8, you get a negative 0.95 when you round to 2 decimal places. This one, when you round to 2 decimal places, is 3.70. Although you may not write the 0 there, it won't matter so much for that one. But there are some other instances with this, because another thing to consider is that you have what is known as the discriminant. That's part of the quadratic formula. And that part of the quadratic formula is the part, and let's make these a little bigger so you can see them. That's the b squared minus 4ac. So when you look at this a value, b value, and c value, you're trying to figure out, is this going to have one real 0, two real zeros, or two non-real zeros? And you do that by looking at the discriminant. Now, sometimes they put it separately, and this one's not asking you to find the actual solutions, but this is something you're doing as part of the quadratic formula anyway. So you can determine along the way what kind of solutions you're going to get. But if we're just looking at the discriminant here and doing b squared minus 4ac, you're going to get 144 minus 4 times 2 times 18, and that's going to equal 0. That means when you go to the quadratic formula and you have that plus or minus the square root part, that's going to become 0. So you're only going to have a single number in the numerator and a single number in the denominator. That's going to give you one real 0. For this situation here, if I use the a, b, and c values I'm seeing here and put that into the discriminant, I end up with 324. Now, whether that's a perfect square or not doesn't matter. That's only going to determine if it's rational or irrational, both of which are real. But because I'm adding or subtracting a square root of a number, I'm going to get two different solutions as a result. They're going to be real. So there are going to be two real zeros for that function. For this one here, using its a, b, and c values, now the b value is 1 because you don't see a coefficient here, and you put it into the discriminant, you're going to get a negative 119. That means you're trying to square root a negative number. And so for this, I know it's going to be two non-real zeros, but what you also learn, and you're going to see this in the upcoming examples, is that we know how to handle situations like this as well, because if they're non-real, they would be called complex or imaginary numbers, and we're going to talk about those in a demonstration and the examples that follow. But for the time being, this is the end of this example and this video. If you have any additional questions, please bring them up during class.